So we're going to continue on learning about interfaces today and, sorting our data. And we're going to answer the rest of these questions. So at the end of last class, we answered the first question, and we sorted our data. You guys remember how we sorted our data? So let's just kind of review what we did. So we took that Excel file, which we can look at in here, or the CSV file. I shouldn't call it an Excel file. It's actually a comma-separated value file. And it had, some employee data inside of it. And each record was on its own line inside of our file. And the top line had our headers, or our field names for our fields. And so we made a class called employee based upon those field names. And we went ahead and we made a constructor that would take in an array of strings that we could then create an object out of, an employee object. So it took in one line or one record, and then it, put it into our instance variables for our employee object. Remember how we converted a string into a double with our wrapper class. That was good that we did that. And then we made some accessors and mutators. And then we made our toString method. And then importantly, when we learned about interfaces, we implemented the comparable interface. Now everyone realizes why we had to implement the comparable interface, right? We kind of ended class sort of fast last time, but do you guys remember why? Someone has to know why. Why we have to implement the comparable interface. Here, watch. I'll take him out and we'll see what breaks. Okay. Okay, one of the reasons that we implemented the comparable interface, or one of the contract items that we had to write when we implemented the comparable interface, was this compare to method. So that broke because we're no longer overriding that method. Okay, but notice if I take out the override, he's okay with that. But notice what else broke. So when I took out the comparable interface, and I'm no longer a comparable object, my employee is no longer a comparable object, what broke here? Our sort. Okay, so we use this static method. We know it's static because we're using a class name to call it. Plus we can look at the Java API and see he's a static method. He's a static method that takes in a parameter of type collection, which is an array list. An array list is a collection. He takes that collection, that array list, and he sorts him based on what? How does he know how to sort him? We sorted him based on salaries. How did he know to sort him based on salary? Yeah, our compare to method. Okay, so we wrote that compare to method so he knew how to sort him, but we also have to assure sort that we actually wrote this method. So Java is a very safe programming language. It does a lot of error checking for us. It does a lot of exception handling for us. And so when this collection is going to sort, he wants to be very much assured that we have told sort that we have created that compare to method. Okay? And so when we implement an interface, we're telling this sort method that yes, we are a comparable object. We have the compare to method. Okay? So when we implement this interface, it's so that we can use the sort. Okay, so we can't use sort unless we are a comparable method. Not method, comparable class. Unless we're a comparable object. Okay? And notice that's what it tells us. It says the method sort is in the type collections is not applicable for the arguments array list employee. It's saying that, hey, our employees aren't comparable. We can't sort them if they're not comparable. I don't know how to sort them. Okay? So, we have to implement this comparable interface, and that tells the sort method that the employee object has this compare to method inside of it, that he is a comparable object. So then the sort knows how to sort things. Okay? So because Java is very safe, it says, okay, I'm not going to sort it unless you're comparable. Comparable says, okay, you can't be comparable unless you write that method. So then sort knows we have that method. Does that make sense? That's why they have interfaces, so that we can get these generic sort methods to work for our objects. Okay? So it can work for our object because we implemented comparable. We're assuring the sort that, hey, yes, we're comparable. And in order to fulfill that contract of being comparable, we wrote this method. So you have to have this method here. Okay? And when we implement comparable and we write that method, now we can sort things. Okay, now he's okay with sorting our list of employee objects. Okay? And everybody sorted it last time, right? Yeah. So we sorted it, and then we figured out that, you know, the last 3 items in our list were our highest paid employees. Okay? Our last 3 elements, last 3 employees in our list were our highest paid employees. So we answered question 1 by implementing our interface and sorting. All right. So now we're going to do number 2, or answer number 2. It says, search for the following employees and retrieve their records. And I gave their first name, middle initial, and last name of Brian, Eric, Lisa, Pedro. And yeah, so those 4 employees. Right? So we're going to write this one together, and then you guys are going to figure out how to write number 3. So, or actually, do you want to do vice versa? Which one do you guys want to write? And number 3 is, what was the average pay for all employees that work in the police department? Yeah, actually, you guys can write number 3. We'll do number 2 together, and then you guys can do number 3. And then we'll do number 4 together. Okay? So we're going to search for some employees and retrieve their records. And then print them out. All right. So to answer these questions, we're going to create a method. Okay? So we'll create a new method in our test class. It makes sense to put it in our test class because our test class has our data structure inside of it that's holding all of our employee objects, which we called list. Okay? So let's write a method to find our employees. And we can think how this method's going to work. Okay? It's going to find that employee object. We'll give it a string with the employee's first name and last name. We can give it 2 parameters, their first name and last name. And then it can return that record of that employee if it finds it. Okay? In fact, okay, cool. So it's going to return an employee object, so the return type can be employee. We can call it something like find employee. It's going to take in a string with the first name. And then it can take in a string for the last name. Note that we have to take in both names because in our records, the first name is separate than the last name. And if it doesn't find that employee, we can return what's called a null object. That means an empty object. So if we don't find our employee, we'll return null. Okay, that's a common thing to do, like in a find function. When you're finding an object, if you don't find that object, sometimes you just return null. Okay, and null just means I'm not pointing to anything. I'm an empty employee object. Okay. All right. So we're going to want to go through our array. That means we want to iterate through our array. Of course, there's different ways that we could do this. Okay. I was thinking the first way that we could kind of implement and write this method is that we could just iterate through our array. Okay. We can search for the last name. When we get a hit and we got that last name, we'll need to check the first name. If the last name and we check both the first name, then we found the person, we can return them. Okay? All right. So to iterate through an array list, you can use a for loop or you can use a for each loop. And since I already have a for each loop written, I'm going to go ahead and use it. All right, so we're going to iterate and we're going to search linearly through our array list. Okay. Now note that our array list is sorted by salary right now. And so we're not sorting by first name, last name. Okay, so we're just going to search, from the beginning of our list to the end of our list. Worst case scenario, the name's not in there. You reach the end of our list. Okay. All right. So we can have an if statement. Actually, we can do this in more than one line of code if we need to. So, actually, sorry. I have my notes here. I should just read them. Okay. So we'll get the first name. So we'll call our list. And you guys remember the so actually we have our object already. Sorry, I was looking at my notes and my notes did not use a for each loop. So actually we already have our object inside of our list, so we can just call our object with the E, because remember when we're iterating with the for each loop, this is the object, this is every object as we hit that object as we're going through our list. Okay, so we can just write E, I called him E, for employee, and we can just get his first name. And so when we put the dot operator there, notice it brings up all of our employee object methods. And we can find get first name. It returns a string, and we can store it in first. And then we can do the same thing to get the last name of that current employee object. This is why it's good to have accessors. Okay. And now we'll make an if statement, and we'll just check that first name against this guy's first name. And I'm going to write it wrong. And what did I do wrong right here? Do you guys know what I do? Yeah. Hopefully everybody knows. I did this on purpose. When you're checking equal equals, what are we actually checking in there? Yeah, memory address. So we need to use a method to compare strings. Okay, so don't ever make that mistake. So we'll use the dot equals ignores case. Notice that we could, use just the equals method, but then if they got the uppercase and lowercase wrong, it would return false. A lot of times we just use equals ignores case. Okay, so that'll check the first name. If that's true, we'll go ahead and check the last name. And then we'll go ahead and return. So if the first name equals, the name that the employee's name or object that we're currently looking at, say, okay, we got a hit. Let's go ahead and check the last name. Alternatively, you could check last name and then first name. You could see which one runs better. But if both of these match, if that's true, then we found the object. What do we need to return right there? What object are we currently on? Yes. Okay. And voila, he is done actually. All right. So now we just need to test him. So we can output what he returns. So we could put this test right inside of an output line if we want. And then the employees we'd like to find, I'm going to go ahead and look online here which employee I want to find. We'll find Brian S. Murphy first. Now if he finds him, he'll return his record to the system out print line. His record will be an object. It'll call the toString method and print out that record. Now if it doesn't find him, we return null and he'll just print out a null. So he prints out a null. And so we need to go to our Excel file and see if Brian S. Murphy is actually in our file. Wait, this is last name. And Brian S. Murphy is in here. Oh, and I see our problem. I think I remember this from last time, actually. So there's two spaces in front of Brian's name. We could use a trim function to get rid of those spaces, or we search for those spaces. Okay. Notice that in our file, because files aren't always made correctly, whatever they use, software they use to create this file, or whoever created this file, put two spaces in there. Okay, you can see that if you put your mouse. A lot of times, if you know something's in your file and it doesn't find it in your file, go and look and see if it put extra spaces in there. This actually happens a lot. Okay, so this is good that this happened. Okay, but it has two extra white spaces in the front there, and those two extra white spaces are counted as part of his name. Okay. And so we can fix this a couple different ways. Okay, we could put two extra white spaces right here. In fact, let's see if there's white space, and there's no white spaces in front of the Murphy, I don't think, no. Okay. Then we can run him and see if he finds him. Yeah, he went ahead and he found him. But then we're counting on our users and we're our searchers to remember that there's two white spaces right there. What's one way that we could fix this permanently? Get rid of those white spaces? You guys know? There is a function called trim. And you could read what trim does. But I think it makes sense to go ahead and use the trim function over here. And it was in his first name. So if you look at the trim function, it returns a string whose value is this string with any leading and trailing white spaces removed. Because this happens so very much, there's actually a string function to help take care of this problem. Okay, so this is actually a common problem in a lot of, databases, a lot of data that you'll deal with in real life. They have lots of leading or trailing white space. So you just conveniently call that method right there. It gets rid of the white space. Okay, I can save this. And notice that I did this in my employee class. That way, even if there isn't any white spaces next time or in the next file I get, when I'm reading in these objects, this will help take care of that problem. So we took care of that problem. So now we can try it without having that white space in there. And it seemed to do the trick. So now we're storing our names without the white space. Did everybody get that? Okay, good. All right, you can search for those other people. Go ahead and search for them. And then search for them also in your Excel file and see if there's a problem with how we searched for them. I want to show you something. So go ahead and search for those other individuals. So search for Eric D. Clark, Lisa M. Hall, and Pedro Adame. Okay, you should find them. I think all of them are present in there. And you can double check by looking in your Excel file. Okay. So let's see, it was Adame, right? So Pedro Adame is inside of our Excel file. You should be able to find him. JKL. Lisa M. Hall. It's in our file. And Eric D. Clark. And then I want you to search for another name. So after you search for those three, you should find them. You should be able to bring up their records. Okay. And then I want to show you something inside of our file. I don't know if you guys have looked at this file carefully. Actually, let's turn off this filter for a second. So I'm just going to sort by last name here. Uh-oh, I killed Excel. And let me find an example of something that's happening in this file that actually happens a lot in files. So I'm looking for an example of something. I Actually, maybe if I do some highlighting cell rules, I can see it better. Actually, that made it worse. And you might realize what I'm looking for in here. What happens in our file? Did you guys look at this file and see what happens in here? Yeah, there's lots of people with the same name. And they're not always next to each other. Yeah, Victor Abro, but his name actually appears next to... where's Victor? Oh, right here. Yeah, there's some people with the same name, and they are the same person. At least I'm assuming they're the same person. And then he was a firefighter, and then he became a senior companion, or maybe vice versa. So because he had two job titles, his name actually got in here twice. Okay? So when we're searching for these names, we can't be assured that we have found the correct record. You guys realize that? You know, for some of our names, we will get the correct record because there's only one instance of that record of that person's name. And because they don't have like some kind of employee ID number inside of this file, we're kind of stuck with searching. If we want to search for their names, we're going to search for their names, and the name appears more than once, we might actually pull up the wrong record. So this is a problem that happens a lot. In fact, some of the names won't even be next to each other. So here's Victor. His names actually appear next to each other, which would be a good way to find, the next name. We could sort by last name, and then if they're next to each other, we could say, oh, okay, which record do you want? Here's two of the records. We could return both records. Okay? But what if the names aren't even next to each other? What if we sorted by last name? I sorted by last name here in the Excel file. And there's actually names in here that are the same. I know I've seen them in here. So if you sort by last name, you can help me look for them. I sorted by last name and then highlighted the duplicates. A lot of the names have duplicate values. And there's some in here. Let me find them. I forgot to write them down. Oh, well, maybe I'll sort by first name too. So in order for us to find these records, there's a couple different algorithms we could do. So if we wanted to find all of the records that go with a certain name, we could search linearly, and then when we find the first one, keep searching to the end. Okay, but that takes a really long time. Okay, that's probably not a very good way to go about doing it. We could sort by last name, and then see if the two names are next to each other. But the only thing is, sometimes in some of these files, or these records, manual will be up here, and then manual will be down here. Okay, so they're not necessarily next to each other. So what we really need to do, and I'll show you right now in Excel what we need to do. We need to sort by the last name. Then we need to sort by the first name also. Like do like a sort within the sort. So we'll add a level to our sort. You add the first name sort from A to Z. So you sort by the last name first, and then you sort by the first name. And in this way, names that are the same will end up next to each other. So here's one. Ricardo Aguilar. Watch, I'll show you when I take away that sort right there. I go and look up Aguilar. Oh, his names are together, okay. But I know... But there are other names in here that aren't necessarily next to each other. Okay. So we could sort by the last name and then sort all of the first names through the last name. But ideally, what we want to do is sort by the last name, do a secondary sort within these last names, and sort the first names. And then when we find the name that we're looking for, we'll look at one more index to see if it's the same name. If it's not the same name, then we know there's only one of him. If we sort by the last name and first name, and there's a second name, then we know that there's two of him. Okay. So the point was that we're going to do two sorts. Okay. So we're going to do a sort on the last name and a sort on the first name within those last names, and then we can look to see if we have duplicate names, because they'll be next to each other. Okay? All right. So we want to do another sort. Okay, we want to sort by last name, sort by first name. But we don't want to wreck our first sort. We still want our salary sort to work. All right? So this actually happens a lot. What do we do when we want to sort some data more than once? So right now when we're sorting our data, we're using that employee compare to method. And we're sorting based on salary. And we don't want to change this. Yeah, we could go in there and then change by last name and then change it by salary when we run the other method, but then they break each other. Okay, and you have to think, okay, this is a common thing to do. There's a way to go about doing this. Okay? And we're studying interfaces. So what we're going to do is we're going to use the comparator interface to kind of solve this type of problem. Okay? Comparator is different than comparable. Okay? Comparator interface is a little bit different. I put a link to the comparator interface here. Actually, this is to the sort that uses the comparator interface. So notice that the sort that we used previously was this sort that did not use the comparator interface. It just had one parameter. But now we're going to use the second sort here that takes a list and it takes a second parameter of type comparator. Okay. What is a comparator? So this is the comparator interface, and it just is a way to create a compare to method that we can use with our array lists. Okay, so it's a way of making a second compare to method. Okay. So if we implement the comparator interface, we have to make the compare method and the equals method. Remember, when you implement an interface, you put implements in the name of the interface, and then you have to implement the two methods. Okay, does that make sense? I think when we do it, it'll make even more sense. All right? So let's go ahead and make a comparator object that we are going to use so that we can resort our data by last name and then by first name. So we need to make a new, actually to implement the comparator interface, you usually make a new class. Okay, a lot of times you'll make a new class to implement this comparator interface. So we'll right click and we'll go to new and we'll go to class and we'll call it employee comparator. We don't need a main method. The only thing that this comparator class is going to do is implement the comparator interface, and it'll have two methods so that we can implement the interface. And we're going to use it so we can sort. Okay. So we'll click finish. And now we'll say we'll implement that interface, because remember that to implement an interface, you do two things. You write implements and the name of the interface you're implementing. Okay. And then it's already telling us, hey, if you implement that comparator interface, then you have to write those methods of the interface. Remember, that was the second rule. Okay. So we can use Java to help us out. We'll hover over that red underline. It'll say add unimplemented methods. It'll even write the method for us. Actually, we only have to write our compare method, which is cool. Now notice what our compare method does. You can go and read in the documentation. But it's going to take two of our objects. And actually, I'm going to undo that real quick. So I'm going to Control-Z that. I want it to be specific for our employee objects, so I'm going to put employee right there. When I write employee right there, then it will write my compare method with employee objects instead of just generic objects. And remember, that's called generics, the little less than, greater than symbols. A lot of the collection classes use that, so then it's adaptable to our objects. Okay. So we'll hover over our red underline again, say add unimplemented methods, and then he names them employee rather than just objects. Kind of makes it more specific. So in this method, we are going to compare the last names and compare then the first names. If they match, we'll go ahead and compare the first names. Remember how compare worked? If the first object was greater than the second object, you returned a positive number. If the two objects are equal, you return 0. And if the first object was less than the second object, you returned a negative 1, or a negative number. Okay, and that's how compare works. All right. So we're going to compare the first, or the last names first. So int result equals. Now I think I'm going to rename these guys. What should we call them? I can rename my parameters there. Use Zolat. I'm going to go ahead and compare their last names. So I'll get their last name. I could compare their first names too first. Now I'm going to use the compare to method in the string class. The string class is a comparable object. A string is a comparable object. They've implemented the comparable interface in strings. So they have a compare to method that I can use. And the compare to method for the string class works just like the compare method that we need. It returns 0 if they're the same. It returns 1 if the first name is greater than the second name. It returns negative if the first name is less than the second name. Okay? So then I would just get the other employee's last name, employee2.getLastName. So I get employee's 1's last name and I compare it to employee 2's last name. I then store that result inside of an integer. So this integer is going to be 0 if they're the same name. It's going to be 1 if, if the first name's greater, and then it's going to be negative 1 if the last name or the other name's less than. Okay? So then I can use that result in my if statement. Okay, so if my result equals 0, it means the names match. The last names match, right? Like if that's true, I can even put right here, if true, then the last names match. Okay, if the last names match, then I want to see if the first names match. And you guys should be able to know how the first names match. They're going to do it or complete that process the same way. I'll say employee 1 dot get first name compared to employee 2 dot get first name. Okay. I can even copy and paste this and change it to first name. So then we'll compare their first names. So if their last names match, then we go ahead and compare their first names. Actually, this will be what we return, because we only want to check their first names and their last name. So actually, we can return this result. And notice that this is a good result to return. So this is how you can compare more than one thing. If I only wanted to compare just their last names, I would just return this statement. But notice I checked that statement first, and then I check their first names. If their first, if their first names match, it's going to return 0. If their first names don't match, actually, I think that's all right. If their first names don't match, or their last names don't match, then it returns 0. We should not be returning 0 here. What should we be returning here?
Result, right?
So if their their last names didn't match, that result won't be 0, and we'll go ahead and return it there. So now we've made a comparator. Now we can use this object comparator in our sort method to sort now by last name, first name. It'll do a double sort for us. Okay. Then we can see if the two names, we can look for that one name that we knew there was 2 of, right? A couple of the names that we know that there's 2 of, and we can see if we find both of them. So let's go ahead and test him. Actually, let's use a method to test him a little bit here, right? Actually, we'll call it find employee 2, I guess. I thought about calling him find employee with comparator, but that might be a really long name, so we'll just call it find employee 2. So this will be finding the employee the second way, okay, with sorting our array list and then looking at that array list for our last names. So let's sort the list using our comparator. So we'll use our collections.sort. And we'll go ahead and put our list in there. And then our comparator. So note that when we call this sort method now, and we give it our list, and we made a new object of type comparator as our second parameter inside of this, or our second argument inside the sort, it now knows to sort according to what that comparator has told it how to sort. That's how you sort a list a different way without ruining your first sort. Make that comparator object, and then you send in that comparator object. The sort knows when it sees that comparator object, I'm supposed to sort it according to what he told me to sort it. So he knows how to sort that list. Okay. So you make a new comparator object, Send it in there, and now you can sort your list parameters. In fact, should we just print out our list right here? See that he's sorted right? Let's go ahead and just print him out. And we need to return an object because our method is yelling at us, so let's go ahead and just return null. We'll implement the rest of this in a second, but let's just see that he is sorted by last name, and then within those last names, he'll be sorted by first names. Okay. Oh wait, we need to call our method. So he's not going to work unless we call him. And we don't need to print what he returns out. We can just call our method. We will need to send it into string parameters. We're not using those parameters yet, but we still need to put them in there. Or arguments, I should say. And he is working. Sometimes it takes him a little while to work. Mostly what's taking a really long time, I think, is our toString method. And my toString method is still printing all on one line. That's great. I want him to print on separate lines. Let's go ahead and fix it. So if I want my, so notice that my printed all on one line. It looks like it's in the correct order, but he printed all on one line. So to kind of fix that problem, if you've already fixed it, great. But if you wanted to fix that problem, you can go into your toString method in the employee class. We could add a new line character in our toString method inside of the employee class. So this is our employee object class. Go ahead and put /n in there, and then he should put that new line at the end of every employee object. So then he'll print out right. Print out legibly, we can see him. So we should print him to another file. That's what we should do. Alright, so it does look like he's sorted by last name. And we can go in our Excel file where it's a little bit more readable, or we can copy and paste this in Excel. And we could look for Aguilar and look for Ricardo and see that his first names are lined up. Did we ever find some last names or first names that weren't lined up like that? Did anyone find any names that weren't? Before, when I was looking, it was so easy to find them. Find them this way, and then I'll take the sort away. Of course, now that I'm looking at it in front of you guys, I can't find any that aren't next to me. Well, we could use our program to find them too. Did anyone find any names that are the same, that are not next to each other? can write that in our method, but note that they are in the correct order. They should be in the correct order. And it looks like they are, because here's our Aaron, and then it goes in Elvia, Jeffrey, and Kimberly, so J, K, E, J, K. Here's our Abbott, and then it goes Betty, Linus, and Sam, BLS. Ricardo, and Anthony, Jennifer, Rosemary, and Thomas. So it looks like it did our first sort by last names, and then within those last names, it sorted those first names. So you see how it kind of sorted it twice there? Wait, question?
Yeah, this is an employee test file.
That thing is still recording. This thing died. Does that mean it's not recording? Annoying.
Such problems.